dot get underscore height times 0.5, and that's to make our height half what it was before.
Hey, Anya, if you don't mind, could you please share your screen?
Oh crap, it's not my bad. I thought I shared it before. Wait, is it not shared?
Yeah, now it's shared.
What? I thought it was shared before. Do you want me to try that again then? Yo, James.
Yeah, hi, what's up?
Do you want me to try that again then?
No, it's fine, it's fine.
Are you sure?
Actually, the YouTube stream dropped out, so yeah, probably restart.
Do you want me to wait for the YouTube stream to come back on?
No, it's back now. It's back now.
Okay. So the first thing that we're going to do in our class is learn how to do an image. So if we go online to whatever image that we is, so I chose an image of Picklework. You can download whatever image that you want. Just for now, to make it a lot easier on us, save the image in the same folder as your file. So right now, my folder or my thing is called pygame template, and I save my image in the same place. So that way, when we load it, we don't need like a huge file path. So first off, to load the image, we name some variable. Let's say pic is equal to image dot load. Whatever we named it, I think it's pickle dash rip dot jpg. So make sure to include the ending the dot jpg or the dot png every time. That's a super duper common error that I make all the time. And what happens is you're like, yo, why isn't my picture loading? It's probably because you got the file name wrong. Okay, say if you are like me and you don't like having all your images loaded in the same place, and you like some type of organization within your files, if you create a new folder, all you have to do is add a path. So say if I created a new folder called like pictures, and I would just do pictures dash whatever I called it before, and this will give Python our file path as long as your file originally was in the same place as your code. Okay, if we run this program, you'll see that nothing has happened yet. It's still a black screen. That's because we only loaded our image into the code. We need to actually put our image on the screen, and that's called screen.blit. So to blit our image onto the screen, we would do screen.blit at, let's see, say if we wanted to blit our picture at like 10,30, this will put the top left corner of our picture at 10,30 onto the screen. So if we run it, you'll see the top left corner is at 10,30. There are also other things we can do about the picture. Say if we wanted to get the width of our picture, like I downloaded the picture without knowing its width, I would do variable width is equal to pic.get underscore width of our image, and height is equal to pic.get underscore height of our image, and that should give us the width and the height of our image. So if we do print width comma height, it turns out our picture is 970 by 545 pixels. If we actually like look at our picture is way too big for our screen right now, right? So we can also transform or scale the image to however we like. To transform the image, we'll to pick is equal to transform dot scale pick, comma, whatever width and height you want to set it to. So I'll set it to 100, comma, 100. And then so if we run this program now, oh my God. Okay, now if we run the program, you'll see that we have like a tiny, tiny 100 by 100 picture in the corner here. But right now I have another problem with my picture is that it didn't transform to scale. So now like the image's dimensions are messed up. So there isn't any method that I know or like any transform dot whatever function that can transform it. If you know it, that's great. If you don't, maybe like you'll learn it in the future. I don't currently remember one. So what we can do is just use a bit of math to do it. And then so here our width and height variables will come in handy. So if we put that here, let's say we want to transform our picture into half the size it was before. So what we do is pick is equal to transform dot scale of pick dot get width. And then so this gets the width of our picture. And if we want to make our picture overall half of what it was before, then I'll multiply it by 0.5. And then the same thing for the height. And there we multiply it by 0.5. And then so, pick, comma, here we go. Forgot a few brackets. And then if we do that, our picture should turn out half of what it was before if I didn't make an error. Okay. See what happened here is that our pictures, when we times it by 0.5, what came out wasn't an integer. So all we have to do is change these values into an integer. I believe it should work. I hope. Yay, it worked. Okay, so now it's just using a bit of simple math and we can get our picture down to, let's say, half the size, or if you want to make it double the size, 1.5 times the size. But even if I was more picky, what we could do is more math. Say I want to make my picture precisely like 200 pixels more. So to do a bit of math here, let's say new width is equal to pick dot get width. Since our picture is too big, I'll do minus 200 to make it smaller. And then so then I need the ratio of our width to height to maintain that scaling. So when I scale it down, so what I would do is pick dot get width plus 200, or sorry, it's minus 200 now, all over pick dot get width. And then so this new ratio coming up is the ratio that we're going to scale the image down to. So if all I know is that I want to make my image 200 pixels skinnier, and I want to keep the original ratio of the picture, then this ratio that comes up is going to be our new ratio. So that we can use that to find the height. Let's say new height would be pick dot get height times ratio. And then so when we put this new image onto our screen, pick dot we should come out with an image that is 200 pixels skinnier, but also maintain that same ratio. Let's say new. Comma new height. Get rid of this line here, and let's see if this works. Couple the same int errors that we had before, so let's just change these into integers. And I think this should work. I hope. Oh. And so many errors, transform.scale. Nope. There we go. Yes, it finally worked. Okay, so now this new image, after all the syntax errors, is what we come up with. Next, we can also rotate our image if we want. Say that would be, let's rotate pic equals transform dot scale and rotate our image pic at, let's say, 30 degrees. No. Huh. Oh my God, it's not that scale, it's not rotate. My bad. Okay, this works, please. So it looks like it's been rotated 30 degrees, kind of. Oh, it has been rotated 30 degrees over here. So rotating in the positive direction will give you clockwise. So positive is equal to clockwise here. And then so if I rotate it negative 30 degrees, that should give us 30 degrees counterclockwise. Okay. Moving on, we can also flip our image. So let's get rid of this rotation so it doesn't look weird. To flip our image, we do pic equal to transform dot flip. Our picture once again, and then so what happens here is, let's say true, comma true. So this first one right here determines whether or not we flip our image in the x-axis, and this one determines whether or not we flip our image in the y-axis. So if I just make this false for now, this should flip our picture only in the x-axis. And if we run this, I don't remember what the picture is before, but I think it's been flipped in the x-axis. Okay, let's try flipping it in the y-axis. So this turns into false, and this here turns into true. It's been flipped. And I think that's all I have planned for pictures. Oh, we can also choose songs. So wait, as you see right now, I've done all this outside of the while loop. And for now, it doesn't really matter since we're only going through it once. But when we get to movement, we'll need to take everything into the while loop. So to create music, what we do is, let's say, name some song. Our variable's name song is equal to mixer dot music dot load and whatever we named it. So let's say song.mp3. I don't have any songs downloaded right now, but you guys can all feel free to go on to like YouTube or whatever music platform that you have and download a song, and this should work, but make sure you save it again in the same file folder as before. And then so what this will do is it loads up our song, but it hasn't done anything to our program yet. So to actually play the music, we need to do mixer.music.load. And for now, let's put -1, comma 0. So this first parameter here is the amount of times you want your song to play. If I want my song to play twice, I would put 2. -1 makes your song play forever and ever, and it continues looping your song. And the second one right here tells us where to start your song. So if it's at 0, then it's going to start our song at 0 seconds. If I put it at 30, that's going to start our song at 30 seconds. To pause and unpause the music, it's just mixer.music.pause and mixer.music.unpause. So pretty intuitive. If we want to change the volume of our music, what we do is mixer.music.set_volume. And so Python can't really set an exact volume. All it can do is change the volume of the original music. So if I do mixer.music.setVolume at 0.75, our music is going to be 3/4 of what it was before. If I put it at 0.5, it's going to be half of what it was before. If I'm going to do 2, it's going to make it twice as loud. And then what if we want to create a playlist for our music? Because, one song is kind of boring. Then we do mixer.music.queue. I can spell queue. Let's say rap.mp3. And then we can go on to add as many of these as we want. Let's say song 2 or something. Okay, and that should give our program a nice music to listen to. Moving on. Okay, I'm just gonna comment this all out because if we try to load it, that'll give me an error. Font. Okay, so first off, Python has a library of a bunch of fonts that we can access. So if we just print out font.get_font right now, that should pop up a bunch of fonts that we're allowed to use. Oh, look at all these fonts. And so we can choose any of them that we want. Let's say whatever this one is. And then create a new font. Let's name it my font is equal to font.sys_font at Bodoni condensed, comma, let's make all big. And then to actually render the font on the screen, what we need to do is font_render. It is equal to my font dot render. What do you want to say? Let's say hello world, typical Python. True. So what this variable true is, it's a toggle for anti-aliasing. So it doesn't really matter. So just set it to true anyway. I don't know what it does either. The color, we can change the color of our font. So 255, it's in RGB, so this should give us red, I believe. And I hope that works. I think it's covered up by our image. One sec. Let's get rid of the thing to split our image. I don't know why it's not showing up. Judy, do you have any idea why it's not showing up? Judy, are you there? Hello? Moshi, Moshi.
Yes.
Do you know why our font isn't showing up? I think there's a font step that I'm missing in my code somewhere. Not quite sure where I missed it.
Oh, I literally know nothing.
Is James still there?
No, he's not here. Oh, that's
I wonder if it's this green dot.
okay. He says he's
Font at well, it's not. Let's see.
Hey Anya, what's up?
It's been a while since I've done Python, but I think there's something wrong. There's a step missing with my font.
All right, let's see what's up here.
Why it's not showing up on the screen.
Try doing a more generic font, like do like Arial.
I got you. Area. I think that's how I spell it. Nope. Python.
Yeah, you can just draw it onto the screen directly, like with the screen dot split.
What?
So if you just screen dot split the font underscore render and give it a position.
Like this?
No, it's the font underscore render.
Oh. Let's try that. Oh, I see it. Yay! Thank you, James.
You're welcome.
Okay, so we need to split our font to the screen. Man, I love Python. Okay, so screen.split actually puts our font to the screen, not font.render. My bad. Okay, there are also special effects that we can do with our font. Wait, let's make this bigger first so we can see it. There we go. If we want to bold our font, then we would do, say, my font dot set bold, set it, use bold to true, That should bold our font. Yep. There's also my font dot set, let's say italic. I'm going to set that to true. And lastly, my font dot set underline. That's also true. Okay, so I think our font is bolded, italicized, and underlined. Nice. Moving on. We have movement. So movement in Python is, it seems kind of confusing at first, but pretty easy to get. So how Python actually works is it can't really like move anything, but it can draw images super duper fast, which make it look like it's moving something. So, well, actually I do want my pictures. So to say if we want our picture to continually move, what we actually need to happen is we're going to draw that image over and over a bunch of times, and then we're going to draw a black screen underneath it a bunch of times, so it's going to look like it moves. So first, to draw the black screen, we can do screen.fill, and we make it black, so that'd be 0, 0, 0. I need double brackets for this. And that makes our background completely black. And then we do screen.split our image at, let's say 100. And let's create a variable x. So x is going to make our picture move every single time. So x is equal to 0. That means our picture is going to start at the left of the screen. And then so every time we make x plus equals 1, then I think this makes our picture move. Oh, syntax error. What? Oh, I forgot extra brackets. My bad. Aha. Oh, wait. It moved down. Okay, I'm actually stupid. So we named it x even though it's in our y position. There we go. Change the variable to a bit more sense. So what's actually happening to this program right now is that it's going to change the position that we split our image at every time. But since we're filling the screen black underneath of it, it looks like our picture is moving. So actually Python's just running over and over a bunch of times fast, and then every time that picture is doing. And you can see that if we get rid of our screen.fill line, it's just going to look like an entire blob or worm moving downwards. So then we have screen.fill. Moving on, we're going to create collision. And so collision is just to check if like a point and a rectangle coincide. It sounds kind of useless, but it's actually quite useful for games. So like if you have like a box rectangle and a bunch of aliens, you can check that if your box collides with these other boxes that represent aliens, then you die. So the first thing to introduce to you for collision is an object called rect. And so rect is just an object that Python takes to store a bunch of variables, its height, its width, its location. And then we can take that object that Python's made, and then we can do a bunch of collision things like collide point or collide rect. So to create a rect, it's pretty simple. Let's name it my rect is equal to rect, and let's make it at 40, 50 and make it 100 by 200. So this is x, y, the top left corner of it, at position 100, 200 right now. We can do a couple of things with our rect. We can move our rect. So my rect equals my rect dot move, and let's move it one to the right and nothing up for now. And then make sure we do screen dot fill to make not belong to viewer. And that should continuously move our rect, right? Oh, I did not split our rect. Let's see. Man, so long since I did Python. I forgot to draw rect. Judy, is it draw rect or just draw?
I'm pretty sure I'm close.
Pardon?
I'm like close to useless for this kind of stuff.
No, it's not rect. Okay, we'll figure this out. Capital R. Nope, let's search it up. Oh, it's screen.draw.rect. Draw.rect at screen, I believe, comma, what does this say? Images. Nope. What is this? I've never learned this before. Incorrect. Screen.draw my rect. Wait. I remember this now. There we go. I think that should work. No. What? Oh, it's just draw.rect. There we go, it works. Okay. So then as you can see, it moves our rect every time, but since it's inside a running loop, it's going to move it by one each time. Okay, there are other things that we can do with our rect. Collide point. So I don't want to move it anymore. Let's see. Collide point checks if a point, say like your mouse or like some random point that you want, collides with your rect. So I believe for this one, what I did was 300, comma 400. And then so if we want to check if certain points collide with our rect, let's see, print my rect dot collide point. Let's see if it collides with the point 55, comma 60. I think this should print true. And then let's make another one that's false. say 20, 10. And then what this should do is it should print 1, 0. And then so 1 represents true in Python and 0 represents false. So that means to us right now, this here gives us true. That means 55, 60 is inside our rect. And then 20, 10 is outside our rect. That comes in super duper handy when we go into games, other things. There's also another thing, collide rect, so that checks if 2 rectangles overlap each other. So if we create another rect 1 is equal to, say, rect of 40, oh, that's just my rect. So rect 2 is equal to, let's get some different, 140, 150. Let's make it 200 by 200. And our last rectangle, rect 3 is equal to rect 400, 500, and put it at 50, 50. And let's just draw these 3 rects for visualization. Rect 1, rect 3, give them different colors. This first one should be red here because this is our RGB value. So let's make this one blue. And then this one green. So if we go onto our Python thing, this gives us 3 rects. So then now if I do collide rect, it should give us that our red rect 1 should collide with rect 2, I think that's green, and then rect 3 should give us false, right? Yeah, rect 2 is RG green, blue. So then if we go on to print, let's say rect 1 dot collide rect with rect 2, this should give us true, so this should print 0 or 1 here. Otherwise, if we print rect, rect 1 dot collide rect with rect 3, which was the small blue rectangle that we saw before, this should give us 0. Get rid of these that we had before. Yep, 1 and 0. So that's pretty much it for collisions. Since we have 8 minutes left, I think I can teach you guys color collide. Man, it's been a while. Let's see if I remember how to do color collide. Okay, so what color collide is useful for is like games for like mazes or something that's like has a super complicated background. So what happens is getting all those like different wrecks and collisions going to like suck like really bad if we didn't have color collide. And so color collide just takes the image of a certain pixel, and then based on that image of the pixel, we can see if we want, like, say, our guy to move. If the walls of our maze are like green, then wherever our guy hits a green pixel, then we stop moving him. So the first thing we need to do is get our colors. And how to get our colors is call is equal to string dot get at string dot get underscore at. Let's put it inside one of our original rectangles. So like 250, comma 250. That should be inside one of our rectangles, I believe. And if we print call. Oops, oh. Here I know we need to double bracket this. Dot get at. I don't know why Python wants us to double bracket some things, but man. So as you can see, this actually turns out to be black. So I did not choose a pixel inside the rectangle. So 0, 0, 0 is black. And this here is the transparency. So from 0 to 25, 0 is absolutely transparent. You can't see it at all. And 255 is not transparent at all, so we can see it. For now, you can adjust the transparency settings. But if you look into these, say like we didn't control the transparency at all. So if we do nothing here, it's going to just take as not transparent. Let's say if we did it at like 30, that would give us transparency. Now transparency is a bit complicated since you need to create another surface underneath for Python. The easiest way for transparency is actually not to do that. So if I want to make my rectangle or this a little more transparent, what I actually would do is just reduce the colors all a bit. Because the higher the colors, the more saturated the color is. So if I just make my color very unsaturated, like here, I change it from 255 to 100, it gives the same effect as being transparent. So super easy, a lot less of the work. So after we get that color, what we can do is color collide. So then I would say, in motions, I would have like some kind of code like if string dot get call string dot get at let's say like 100, 200. In a game or such, it would be like don't move the player, or like player hits a wall or something during a maze. For now, let's just print hello. And usually in a game, what we would do is we have variables like px representing the x coordinate of the player and like py representing the y coordinate of the player. But for now, we don't have enough time, so we're just going to do this. Oh my bad. Is equal to, let's say, what is it, screen. And it's not, so it doesn't print hello. Okay. Does anybody have any questions? We've got 2 more minutes to our lesson. Any questions? Anything you want to ask me about Python? Okay then. So that pretty much wraps it up for our lesson. Thank you everyone for being here, and I'm sure you'll have a super duper fun time learning lessons. Because if you're in these Python workshops, and you probably haven't taken grade 11 comp or grade 10 comp sci, I think, probably. So if you actually do those classes, you'll learn a lot more than you will in hackathons. And Python's just a fun language, man. Because like once you get into the other languages, you'll just realize how easy Python is. Man, I miss my Python days. So if nobody has any questions, that's going to be it for our lesson. Thank you everyone for coming once again. And I think in a minute, I'll just end our lesson here. Okay. Bye everyone. Have a great time at MasseyHacks, even though it's online this year. Hope you guys win some prizes, learn some things, and thank you for being here.